Hey everybody, welcome back to the channel. Today we are going to be discussing something new. In the previous episode, we did systems of equations, and I really wanted to say thank you because that was so far my most popular video. Seems like you guys really enjoyed it. So today we're going to still be sticking with the linear side of algebra, and we're going to expand by discussing inequalities. Now, what are inequalities? Inequalities are basically mathematical expressions that will compare two values using symbols like these. Now, what are these symbols? Now, in our usual, we have had the equal sign, but now we're going to be discussing inequalities, which basically the expressions are not quite equal to each other. So instead of expressing a range of just one value, inequalities express ranges of possible solutions rather than just one value. So we'll have an example down here. So we'll have the expression by using x as our variable today. X is greater than 3. Now, what does that mean? The inequality x greater than 3 means that x can be any number greater than 3, like 4. 4 greater than 3, it works. It solves the equation. It proves it. It works. Anything greater than 3, from 4 to 5 to 100 to 1 million to infinity and beyond, all the way to the end. And the easiest way to visualize this is with a number line. So we are going to make a number line, and our dot will serve as 0, 1, 2, 3, 4, 5, 6, and to the left we'll have our negative numbers. Now, the expression x is greater than 3 is about right here. So we'll go through what each symbols up here mean. This symbol means less than. If, for example, x is less than 2, that means the only thing that will satisfy this equation is values x being less than 2. So like 1, 0, -1, and so forth. This we just went over is the greater than symbol. Sorry, I should underline this. Greater than, less than. And then the 2 up here with the line underneath it means less than or equal to, and this one means greater than or equal to. Now, they're pretty much the exact same thing except just one key difference, or equal to. So if we had the expression x is greater than or equal to 1, so like before, any values greater than 1 will satisfy this, like 2, 3, 4, but the if x is equal to 1, this also will solve this equation to satisfy, because we have this little symbol down here that shows that x equals 1 will also satisfy this equation. That's what it means. Greater than or equal to. It can be equal to that value or it can be greater than. And same with x is less than 1. So 1 is equal to, therefore it'll solve it. 0 is less than, so forth, so on. Those are the major differences. Now, the way we designate the differences on a number line is if it's just greater than, like up here, we will indicate with the open dot. So we will not close it, just an open dot, and we will typically, let me use a different color just to make it easier. So we put a open dot on the 3, and then we're going to go to the right of the number line. Since it's greater than means you're going to go to the right of the number line. So by indicating that the open dot is on the 3, that means 3 will not satisfy the requirement. For reference, we are talking about this here, not that down there. So we see 4, 5, 6 solve it, but 3 won't. Now if we go to the other side of the equation, and let's say we use x is less than 2. Okay, so we got to find 2 on our number line right here. We see it's only less than, not less than or equal to, so we will indicate it with the open dot. Now, less than just means everything to the left of a number line. It's the opposite of greater than. So we will just draw an arrow and go here. And we see that all these values satisfy. Now, what about the less than or equal to or the greater than or equal to requirements? So now, let's use the ones down here. X greater than or equal to 1. So now, since 1 is included in this possible range of solutions, since it's an equal to expression, we will indicate it by a closed dot like this and go to the right of the number line. Because now it shows to the reader, or whenever you're writing this on the exams, that, okay, the person who just did this exam showed that, okay, 1 is also included in this set. And then vice versa. If we did x is less than 1 using red, open dot, go to the left of the number line. And that is pretty much it. That's like the discernible difference. And those are the basics of inequalities. But we can do so much more with inequalities. We can also use it for equations. So it's going to be the exact same process like linear equation, like what we did before, like one-step, two-step equations, except now, instead of an equal sign, we're going to have these inequality expressions. So we'll start with our first example. We will do an easy one. X minus 4 is greater than 2. So let's go through our rules of algebra once again. We want to have all variables on one side. So we want the x's to be on one side, and we want our coefficients or our numbers to be on the right side. So we see that x is already positive on this side, so there's no point moving to the right side. We're going to leave on the left side. What we are going to do is move 4. Now, to get move 4, what you do on one side, you do to the other. So since it's negative 4, you have to add 4 to get rid of it. And what you do on one side, you do on the other. The exact same process. So negative 4 plus 4 is just 0, so we're left with x on the side. Don't forget our greater than symbol. And then 2 plus 4 is 6. So now we get this expression that x is greater than 6. And if we bring out the number line again, and if the teacher ever asks you to prove it on number line, we will find 6. Since it's just the normal greater than sign, it's just an open dot and everything to the right of the number line. But in red to make it easy. And that's pretty much it. And the sign will stay the same. Do not change the sign. There is a situation where you have to change the sign, but we will get to that later. That's pretty much it. You just solve it like a normal linear equation. Same rules, same concepts. So we'll try another one. This time we will do x plus 9 less than or equal to 14. Okay, let's go through the rules again. So x is positive on the left side, so we're just going to leave it there. There's no more x's. We want to move the 9 to the side where there's the 14. So how are we going to do that? So we have positive 9, so we're just going to subtract the 9. And what you do on one side, you do to the other. Cross it out. Now all we're left with on the left side is x less than or equal to, keep the sign. Now 14 minus 9 is just 5. This is our expression. And now to visualize it on a number line, I'll make it in blue. So since it's a less than or equal to symbol indicated by the little line underneath it, we will have to make it a closed dot. So we look at 5, 5, and then everything to the left. Remember, greater than or equal to, it's everything to the right. Less than or equal to, it's everything to the left of the number line. Yeah, and that is just your single step inequalities. So now we're going to go into something called, we're going to go into two-step, and then we're going to go into the special cases. So let's start solving with two-step equations now. So let's say we have 2x plus 4 is greater than 12. So, like before, we see that we have 2x plus 4 on one side, and it's just going to be easier if we leave 2x on the left and move 4 to the right side. So the only way to do that is to subtract 4. You do what you do on the left, you do on the right. So 4 minus 4 is 0. This is 2x. Greater than symbol stay the same. 12 minus 4 is 8. Now, this expression is partially complete, but often you will want a simplified version. You can leave it as 2x greater than 8, but for simplicity, let's just get the x by itself. To do that, we just have to divide by 2. And then what you do on one side, you do the other. 2 divided by 2 is 1 on this side, so we just have x. Greater than symbol says the same. And then 8 divided by 2 is just 4. So now we have the expression x greater than 4. And just for a little bit of memory, I gotta make this a lot bigger. Make that 8, 2, 5, 6. And if we use orange this time, so we see it's just greater than, not greater than or equal to. We're just gonna have an open dot like this. Greater than, everything to the right of the number line. And these answers are easily checkable in your head. Just, if you want to use this original equation, what you can do is, so we know this expression down here, x greater than 4. So let's plug in a number to prove it. But let's plug in a number that is greater than 4. Let's do 6 in this original equation. 2 times 6 plus 4 greater than 12, that's the x. So we have 12 plus 4 greater than 12, which is then 16 greater than 12. Oh, it satisfies. And it's a simple way to just check your answer to make sure that you solved the inequality right. It's just a surefire way, and you can even do it for this and this. You can do it for all these inequalities. Surefire way to check your answer. And now I want to show you, what if we plugged in 4? Well, if we plugged in 4, we got 2 times 4 plus 4 greater than 12. 8 plus 4 greater than 12. 12 greater than 12. Now, a lot of people will look at this and say, well, they're both equal on the other side, so it must be true. Not at all. See, if the expression was like this would be right, but it's not. We only have the greater than symbol. 12 is not greater than 12, so therefore this expression is deemed incorrect, and 4 is not a viable solution. Everything greater than 4 is a viable solution, indicated by this expression we got here. All values of x greater than 4. Now this does include fractions. I haven't gone into fractions yet. I'll go that to a different video, but just to tease and hint at it, if you plugged in 4.5, this would be greater than 12, or it would have been greater than 4. 4.5 is greater than 4, so therefore that also, so fractions satisfy these as well. It's not just whole numbers and integers. And I'm going to go into one last thing on this video, the special case. So we're going to start off with a negative number this time. We're going to have negative 3x minus 3 greater than 6. Okay, so what we have is negative 3x minus 3 greater than 6. So let's just leave the negative 3x on the left side. And let's move the 3 to the other side, right? So negative 3, how do you do that? Well, to get rid of negative 3, you have to add 3 plus 3. You do it on the other side as well. So then you have negative 3x is greater than 9. You have this expression, and this is where the special rule comes into play. When you are in this situation and you have to divide by a negative to simplify the expression, you also will have to flip the sign. So I'll show you. So we'll divide by negative 3. So negative 3 divided by negative 3 is 1. This makes positive x. I'll leave this blank here for a minute. And then 9 divided by negative 3 is negative 3. And now, instead of the greater than symbol that we've been keeping, we're going to flip it and make it a less than symbol. And it's the same process. If this was a less than in the beginning, it's going to flip to a greater than. If it was a less than or equal to, it's going to flip to a greater than or equal to. Greater than or equal to a less than equal to. Now, why do you flip the sign when you divide by a negative number? When you divide or multiply both, or this applies to multiplication, if you multiply both sides of an inequality by a negative number, you have to flip the direction. Why? Because it keeps the expression true. So if we had an example down here, like -2 is less than 4. This is a true expression. -2 is smaller than 4. It's to the left of the number line. It makes sense. Now, let's say we wanted to simplify this. If we divided both sides by -2, we get -1, -2. Now, let's say, what if we didn't flip the sign? We keep it a less than symbol. Oh, sorry, +1, my fault. Now we have this expression, 1 is less than -2. This is not a true thing. This is not true. This is why we flip the sign. It reflects how negative numbers reverse the direction of values on a number line. And now if we did it properly, if we flipped less than to greater than, oh, this expression turns out to be true. So you flip the sign to keep the expression true. 1 is greater than -2, but it's the same thing here.